Okay, a segment of ALEKS statistics we will be looking at in the hypothesis test about the standard deviation. Okay, so let's read the problem. The cholesterol levels of adult males are approximately normally distributed with a mean of 223 milligrams per deciliter and a standard deviation sigma of 21.3. Now, some researchers claim that the standard deviation of cholesterol levels of adult males is greater than 21.3. So there's a key text right there. Here's our claim. Now, a sample of 17 adult males' blood tests had a mean of 221.5, standard deviation of 29.2. Is there enough evidence to conclude at the 0.01 level of significance that the standard deviation of cholesterol levels of adult males is greater than 21.3? So they tell us to perform a one-tail test. If we look on down through the list here, notice that they're asking us for critical values, not p-values. So if we're dealing with critical values, we're going to be doing a traditional test. And so let's go over here and take a look at our formulas for just a second. And notice here that we're making a claim about a population standard deviation. So we have basically here in our hypothesis test for the standard deviation, we can see here that we're going to be dealing with a chi-square situation. And so chi-square is going to be the name of the game here. Let's go ahead and get some of this set up. And you've done a lot of this before. I'll go ahead and get the claim section written up and we'll check it. Okay, I got some of this done for you now, and hopefully you've done the same thing. First of all, here in the claim section, we're claiming that the standard deviation is greater than 21.3, so in symbols, we use the symbol sigma here. Be careful on this particular problem. Sometimes they ask for the variance, and the variance, of course, is sigma square. So the symbol for variance, sigma square. But for standard deviation, just sigma. And of course the opposite of that, less than or equal to, which of course becomes our null hypothesis. So got those set up here as before. Now for the critical values, now since this is a traditional test, we're going to be dealing with critical values of chi-square. And so notice here that the type of test, according to the sign of H1 up here, of course, remember, is greater than, so it's a right tail test. It's chi-square because we're dealing with the hypothesis test for the population standard deviation. So when you go to the formula in the formula sheet, you'll see that's a chi-square. So the test is right tail chi-square with a percent unsure of 0.01. Now, of course, all of that 0.01 is going to be crowded over here into the right-hand side. And so the all of this area then is over here. What we're going to want is this chi-square value right here. Of course, since it's on the right-hand side, we like that, and so does the ALEKS calculator. So we can simply go up here, hit our calculator button. We're going to go to the chi-square button here. We're going to have this 0.01, which is to the right. Now, of course, notice here that the chi-square distribution is a degrees of freedom distribution. And since we have a sample size of 17 males, we're going to have a degree of freedom of 16. So we need to enter that into our chi-square calculation, and we get then 31.9999, or in fact, rounding that to 3 decimal places, that's going to be 32.000. So down here in the answer section, I've taken the liberty of filling in already the values that we got in the claim section. It is a chi-square with 16 degrees of freedom. The critical value, and I'll go ahead and put that in now at 32.000. And now we need to go back over here and calculate our test statistic. So let's go back and do that. We've got the formula steps set up. Here, notice that we have a sample size of 17. Careful here now. We have two different standard deviations going on. We have the sample standard deviation, and we have then the population standard deviation. Notice that the population standard deviation sigma is in this claim up here. Okay, so get those to match. Oftentimes what students do to get this wrong is they switch these. these two values get switched, and that messes things up for us. So let's go ahead and get those values plugged in, and then we'll calculate that chi-square test statistic. Okay, got some of the done here. Now notice here that n minus 1 would be 16, 29.2 squared, and then 21.3 squared. So let's calculate that value. Notice that the answer we're getting for that is 30.069 with a 5 after that. So in ALEKS here, let's see if they want 3 decimal places, which they do. So we're going to give that 30.070 to 3 decimal places. Okay, and so what we need to do now is to go back to our notes and finish the test. Okay, moving on to the most important part of any hypothesis test, the comparison section, where the decision is actually made. Notice here that first thing we do is draw the number line, and in chi-square you don't have any negative values, so the chi-square number line must start at 0 and go to the right. Notice here that we have a critical value up here of 32, so here at 32.000 we have the onset of the critical region. Since it's a right tail test, that critical region is going to go to the right only over in here like this. Now once again, remember, if our calculated value, our test statistic, falls inside of this critical region, we'll reject the null hypothesis, and otherwise, if it falls over in here, we will fail to reject. Our calculated value this time, our test statistic, was 30.070, so that's going to fall short. That 30.070 is just barely past the 30 over here, so that will not, in fact, fall in the critical region. It's close, but there is not quite enough evidence to make that work. So we are going to be forced into failing to reject our null hypothesis in this case. Now again, here we are not really sure what we have until we run this through the diamonds. So I tell people here, don't try to figure this out without the chart. So let's go over here and take a look at our chart and see what we have. Now the first box on the chart says, does the original claim contain the condition of equality? And we see here the original claim was that the standard deviation was greater than. So did the original claim, the symbolic claim, have an equals in it? And you say, no, it did not. So we're going to follow the no branch of the chart. In the no branch of the chart, did we reject? And actually, no, we were close, but we did not reject. So there is not sufficient sample evidence to support the claim. Let's go back to ALEKS now and see the final question. Can we support the claim? And we say no, there was not enough evidence to support the claim. Let's go ahead and check the problem. And we are good to go.